Suppose an African safari touring company claims that on the tour, the probability you see a giraffe is 75%. So the probability of seeing a giraffe is equal to 75%. The probability of seeing an elephant is equal to 65%. And the probability that you see both a giraffe and an elephant, so this is the intersection, giraffe and elephant, is equal to 55%. What is the probability you don't see either a giraffe or an elephant? So we want to know the probability of 1 minus the probability of G or elephant. We want to find the complement of this. So the best way that we can do this is drawing the Venn diagram. So I'm going to draw my two circles for my events, giraffe, seeing a giraffe, and seeing an elephant. And in here, I'm going to start with my intersection. We always start with the intersection first, so 55% is the likelihood that I see both a giraffe and an elephant. Now I move out to the circles. So this entire circle is 75%, so that means that the leftover will be 20%. Now this entire circle of elephant adds up to 65%, so the leftover will be 10%. Now, if I want to know the probability we don't see either a giraffe or an elephant, that's going to be this area out here, essentially not fitting into either of our circles. So if we add up these circles, we find that this is then 85%. So the leftover 100%, because that's what my entire sample space must be, minus 85% will be 15%. So if we want to do this using the formula, this is 1 minus the probability of G or E, which again, using the general addition rule, we can find this to be equal to probability of G plus the probability of E minus the probability of G and E, which is equal to 1 minus the probability of G, 75%, plus the 65% for E, minus the 55%, our intersection. And once again, we get that the union is equal to 85%. But because we want to find basically that not happening, I don't see either a giraffe or an elephant, then I'm going to take the complement. So that's 1 minus the event occurring, then this is equal to 15%. So either way, using the formula or using the Venn diagram, you can find this probability. My suggestion is using the Venn diagram for this one. It's a little bit easier to visualize, and we know that the entire sample space must add to 1.